my name is Amy Reeser, and this is my assignment 4, Revisions and Rationale for my teaching unit. I teach geometry in Olathe, Kansas, and this year I teach mostly sophomores, but I do have a few juniors in the mix. My goals for my teaching unit were about three-dimensional figures and naming three-dimensional shapes, which can be classified as polyhedra or non-polyhedra, and I've put some examples at the bottom of the screen there. The first picture is an example of a polyhedron, a three-dimensional shape with straight edges and polygon faces. The second picture is a cone, and that's an example of a non-polyhedra because it has curved edges. In this unit, I also taught my students how to draw multiple representations of three-dimensional figures, such as the isometric and orthographic drawings, which that's the third and the fourth picture at the bottom of the screen there. And then I also taught my students about cross sections, which is when you take a three-dimensional shape and you cut through it with a two-dimensional plane and the two-dimensional shape that results from it. In order to talk about whether or not I thought the tasks yielded appropriate evidence of the identified understandings, I thought that you should first know what the learner objectives were. So I have them listed here, but I will also list them as I go through the different tasks. So the first learner objective was, by the end of the unit, the learner will be able to differentiate between polyhedra and non-polyhedra, and also name three-dimensional figures based upon the shape of their base or bases, or with special vocabulary. So the first thing I did was I projected a group of 9 three-dimensional figures, and I told the students to put them into 3 groups of 3. I gave them no further instructions other than to group them based on what they visually looked like. And I then drew 3 names of students, and those students then shared one of their groups and their explanation behind why they grouped them. And if nothing else, this is a really good pre-assessment for me because it turns out my students really do know a lot about three-dimensional figures. They just don't necessarily know the formal definitions behind prisms and pyramids and non-polyhedra shapes. So I was really impressed with what they already knew. And I also did guided notes for this, led them through those formal definitions. We sketched figures with given dimensions and then identified them as polyhedra and non-polyhedra, and this was done both in class and for homework. I was also able to use a new software that I found called SketchUp to demonstrate turning two-dimensional shapes into three-dimensional shapes, and I will actually show you an example of that. What's really nice about this SketchUp software is that I am able to rotate these shapes and show them from all different faces and from all different views, but it also allows me to show how we can take a two-dimensional shape and give it depth or height to make it three-dimensional shape. So it was really nice to have access to this software for this lesson. And then I also had a set of flexible plastic nets, and at the bottom right you'll see a picture of a net of a triangular prism. So a net is a two-dimensional representation that, if you were to fold it up, would make a three-dimensional shape. The second set of learner objectives were, by the end of the unit, the learner will be able to determine various cross-sections of three-dimensional figures and describe how to create a desired three-dimensional cross-section. Again, I was able to use the SketchUp software for that, which I'll show you in a moment. I was hoping to do Play-Doh with this because I've done it in the past, and I have the students make three-dimensional shapes and then cut through the three-dimensional shape, cut through the Play-Doh to explore the cross-sections. And unfortunately, I did not have time to do that this year. And then we also practice these concepts on guided notes and on homework. So possible revisions would be maybe training the students to use SketchUp on their own so that they can create the three-dimensional drawings as opposed to the paper and pencil, but then also, especially to get the Play-Doh activity in there too, I really think that I need to allow more than 2 50-minute class periods for this, which is what I was able to do this year. And I know that that's wishful thinking sometimes, but I think that that would have really benefited the students' understanding. I also had a learner objective for the students to be able to draw orthographic and isometric representations of three-dimensional figures. I was able to do an activity for this one called the Build It activity, where I give 6 clues, and the students are given about 20 colored 1 centimeter by 1 centimeter by 1 centimeter cubes. And based upon the 6 clues, the students had to create these structures, and then we used those structures to practice drawing the isometric and orthographic views. And it also allowed a good informal formative check for understanding of key vocabulary that we had learned earlier in the unit, such as faces, vertices, and edges. And I really liked that it forced the students to use problem-solving skills within the learning. Do I consider the tasks to be complex and real world? I do think that there were some complex tasks, such as the build-it activity. It was a good hands-on experience. They had to use problem-solving skills. Do I feel like it was real world? I think that you use problem-solving in your everyday life. But again, I think that we could have really expanded upon that, especially with the Play-Doh activity. And I thought, too, to make it more real world, to think about ways that we could use these three-dimensional ideas, such as the structure of buildings and houses and architecture, and maybe even get involved in something like a Habitat for Humanity building project, and think about different views and different ways that we could use our knowledge in an application like that. So that would be a possible revision for my unit as well. As far as assessments go, I did some formative assessments, observation, especially the looks on the students' faces as I was going through the material, class discussions and their responses. I could see their practice drawing three-dimensional shapes in class and give them immediate feedback with that. I was also able to give them feedback and they themselves as they were correcting their homework and their practice. And then being able to see their isometric and orthographic drawings in class and give them feedback on that as well. The summative assessment was the 12-1 quiz and eventually the Chapter 12 test, which involved them drawing isometric views and orthographic views and naming polyhedra and non-polyhedra and explaining why or why not. So it included all of the learning objectives that I mentioned earlier. Did the students have an opportunity to self-assess? I really feel like this could be an area for improvement. There's a lot of responsibility put on the students for completing their homework before they get to class and then grading it and making corrections in class. So I think that it would be beneficial if they had another opportunity, maybe having the students write about their mistakes so that they could avoid them in the future. And they do have a chance also to compare their answers and drawings with others in class. So I do think that I could be better about that and maybe have them expand more on their mistakes and hopefully learn from them and not make them again. So that's all I have. Thanks for listening.